Hi everyone, welcome in new energy efficiency tip of the day. Our subject today will be related to steam system low efficiency problems. We want to discuss the reason for the low efficiency. The first reason we may have will be boiler frequent on-off cycles. This will result in loss of energy during the startup cycles because part of the energy will be given to the casing for preheating the casing whenever we are starting the boiler, beside the other part that giving to the water to generate the steam. So when we are repeatedly doing this, we will lose a significant amount of energy for preheating the casing. The solution could be ensuring boiler continuous operation at good load and adjusting steam consumers load to keep the boiler load above the minimum turn down ratio to ensure the boiler working in a good efficiency zone. Also, we can review the boiler's load sharing and control concepts if we have multiple boilers in our system. The second problem could be boiler operation at lower pressure than the design pressure. This will result in losing efficiency at low pressure. Also will increase the radiation and convection losses. This will lower the quality of steam produced because the foaming formation tendency will be higher. On the other hand, the possibility of steam priming, which is water carryover with load change, will be higher because most of the time at this case you will find the boiler working at a higher level with some high foam giving you misleading on the level here. So the carryover will be really crucial and could damage downstream superheaters because of the thermal stresses that can make for it. The solution will be operating the boiler at pressure close to design pressure to ensure stable leveling inside the boiler and optimum operation, adjusting the boiler pressure at the design, and also using let-down valves near the consumer to adjust the steam pressure to the required pressure. We can also check the feasibility of using let-down extraction turbine instead of let-down valve to recover this energy rather than losing this across the valve. The next problem will be high steam velocity in pipes. This means we are working with velocity more than 30 meters per second for the steam. This can happen when we are adding more steam quantities more than the steam pipe size can handle. This will result in noise, vibration in the steam lines. This can cause water hammer if we have a condensation. On the long term, this will cause pipes erosion also. The solution will be checking our existing system velocity in our steam network before we plan or we add any amount, so we can also plan for any required debottleneck before adding this additional amount. Also, we should consider the proper pipe sizing during the design with enough margin or when we are adding any additional amount. The next problem will be water hammering and condensation. This can happen during the startup when we are not removing the startup condensate. The result will be, as we said before, noise, vibration in the steam lines, steam leaks, and even possibly piping joint failure. The solution will be ensuring removing the condensate from the steam pipes. We can check the steam traps and the drain during the system startup and operation. The good selection for the steam traps also is crucial here. Applying regular maintenance plan for the steam traps is very important. The next problem will be defected steam system insulation. If we have defected insulation in place, this will result in loss of energy. Just to give you example, we may lose 1.5 kilograms of steam per hour per meter of pipe. As we said, this could be condensed by losing energy without insulation. This is applicable for example, a steam system at 7 bar pressure. So if we imagine that we have a longer pipe which is without insulation or the insulation damaged, this will be significant loss for the operation. The proposed solution will be ensuring good insulation in place, definitely. Check the condition of the system insulation by applying maintenance required immediately, and don't leave any line after maintenance without insulation. So we can consider having insulation upgrade, as we said in the previous video related to thermal insulation, when we for the old system when we have any chance. We can also have a scanning using our thermal camera to detect the defected areas and apply required maintenance for it. The next problem will be the presence of air and non-condensable gases in our steam system. Actually, the air will work as a buffer and will hinder the amount of heat transfer for the steam. So the result will be poor heat transfer, corrosion due to acidity with condensates because that small amount of CO2 with the air, reducing generated steam temperature, as we said. And in some cases we have seen that also people start the system and found that the temperature is not rising as they expect, or the steam system is temperature is not okay because of the amount of air was not properly vented. So the solution will be ensure the air removal from the system using air vents that installed in all the steam system for during the startup. Regular check for the steam traps. Also, steam trap responsible for releasing this kind of non-condensable gases like air. As we have seen, there is a common result for all those problems will be that higher operation and maintenance cost, and we wanted to avoid this as much as we can. The last part here in our video will be talking about the quantified energy saving opportunities for the boilers. So we want to mention quickly where are the opportunities where we can save energy. As we said, improved operation and maintenance of the boiler can save up to 5% of the overall energy consumption. Improving water treatment and boiler water conditioning can save about 2%. If we enhanced our total dissolved solid TDS control and boiler blow down, we can save about 2%. If we applied blow down heat recovery, we can save up to 4%. Boiler burner management system or digital combustion control and oxygen trim, we can also reach 5% in the good case. If we are using economizers, also this can give us 5% saving. If we are preheating our combustion air, we can also add 2% to our saving via this action. Thank you so much for your listening. I hope you have enjoyed this small and quick tip. I will leave a link to download a PDF format of this map for you to use it in the future or share it with your colleagues to increase the energy efficiency awareness. At the end, I want to thank you again for your time, for your listening. You can find more tips in my website 360proactiveengineer.com. Any improvement, comments or proposal from your side, always welcome. Thank you so much and see you in the next step.